All right, so this is the first practice problem, so to speak. So you have 10 mLs of hydrochloric acid and it's dispensed to an Erlenmeyer flask using a pipette, or volumetric pipette, I'm sorry. 25 mLs of water is added to the flask and 3 drops of phenolphthalein. Remember, phenolphthalein is the indicator that will turn pink when it's exposed to hydroxide groups. So 0.4 molar solution of sodium hydroxide is poured into a burette and the initial volume is read at 0.51 milliliters. The sodium hydroxide solution is added to the flask in 1 ml increments until a pink color briefly appeared and then disappeared. The NaOH was then added drop by drop until the pink color lingered for 30 seconds. Then the final volume of NaOH was read at 18.50 milliliters. Find the molarity of the hydrochloric acid solution. So here you have the 4 steps to finding it. So first you got to find the volume of the titrant and then convert that to liters. So you have your total volume, which is your final volume minus your initial volume. So your final volume was told 18.50 milliliters minus 0.51 milliliters. So your total volume is 17.99 milliliters. Convert this to liters. You should know how to do that by multiplying by 1 liter over 1,000 milliliters or by dividing by 1,000. So my total volume of the titrant is 0.01799 liters of NaOH. Find the moles of NaOH. So you're going to take your volume in liters and multiply that by the molarity. Of NaOH. So 0.400 moles of NaOH, over 1 liter. So my moles of NaOH is going to be 0.007196 moles NaOH. So this part here, relate moles of NaOH to moles of HCl. Basically, you just use a balanced equation to determine the moles of HCl. And let's just double check that this is all balanced out. So just be mindful, what you're doing is you're going to take your moles of NaOH and then multiply it by the mole to mole ratio from 1 mole of NaOH to 1 mole of HCl. Remember those numbers in the mole to mole ratio come from the coefficients of the balanced equation. So luckily for us, it's still the same number, just different units. Find the molarity of HCl by dividing moles by volume originally dispensed in the Erlenmeyer flask. So you're going to take your moles of HCl and then divide it by the volume of HCl given in the problem, which is 10 mLs. So 10 mLs is 0.0130 liters of HCl. Keep in mind your sig figs when you're doing these problems. So divide it, 0.7196 m. So I'm looking, the 3 drops, that doesn't count for sig figs. When you're doing your math, the smallest number we used was actually, smallest number sig figs was from the 0.400. So that would mean that my answer is going to be 0.720 molar HCl. So reading this, calculate the amount of H2O2 in grams in the sample if 1 ml of H2O2 solution required 15.10 mLs of 0.0250 molar KMnO4. So what do we know? We know that 15.10 mLs of 0.250 molar solution KMnO4 is used to react completely with 1 ml of hydrogen peroxide. So you'll notice that they took out the distracting ions, or distractors, if you will, spectators, in this reaction. They left us with the following in the reaction itself. So MnO4, or this right here, excuse me, MnO4, this forms a pinkish solution and it's in the titrant. I apologize, it's not in the titrant, it's in the burette. So the first step we're going to do is to find the moles of potassium permanganate. So we are going to multiply the known volume of the titrant, so the KMnO4, by the known molarity given in the problem. And this will give us the moles, but make sure that your volume is in, make sure your volume is in liters when you're doing this. So I got 3.75 times 10 to the negative 4 moles KMnO4. So now we take our moles of KMnO4 and then convert that to we'll convert that to moles of H2O2 by using our balanced equation. So 2 moles of MnO4. That's ugly. And then on top it's going to be 5 moles of H2O2. Then from here, I'm going to convert these moles into grams. So 1 mole of H2O2. So from here, I'm going to get my molar mass, and I'm just going to round it, you can say. It's going to be CO2, so 16 times 2 plus 1 and 1, so it's going to be approximately 34 grams of H2O2, and from there I will get my mass. So the 3.75 times 10 negative 4 times 5 times 34 divided by 2, my answer is going to be 0.31875. So you're going to see that for sig figs, it's used this one right here, the molar solution. So it's going to be 0.0319 grams H2O2. All right, so that's it for the notes, the problem-solving notes for this particular lesson, this particular topic. So if you have any questions, please let me know. And hit that like and subscribe.